Up until this point, we've been using pre-made rocket designs. Now let's create our own rocket from scratch. The critical dimensions for the rocket are listed below this video, and you can also find a reference design on Tinkercad. In Tinkercad, click on the magnifying glass icon and run a search for S. La Rochelle 0769. Then click on People, click on my picture, and scroll down to Reference Air Rocket Critical Dimensions. Click in the middle and choose Copy and Tinker. From here, if you don't see the design, you can see that it's up in the corner for some reason. On your keyboard, use Command A to select everything, and then tap the F key. That will bring everything into focus. Now here, some of the components have notes, and if you click on the note, you'll see that for the rocket body, you use a cylinder. The inner dimension should be 21.9 millimeters. The outer dimension should be 23.4 millimeters, which will leave you a wall thickness of 0.75 millimeters. And for the nose cone, the outer radius should be 11.7, and so forth for the fins. Now this is just for your reference only. As I say, the dimensions are all listed below this video, and throughout the rest of this video, I'll go through step by step in creating all of the components for your air rocket. For the rocket body, we'll drag out a cylinder, and if we tap the F key to zoom in or focus on this shape, we see that the outer surface is rough. It actually has 20 sides. To make it smoother, we'll slide the side slider all the way over to the right, 64, and that makes it much smoother. Next, we know that the outer diameter needs to be 23.4 by 23.4. So that's all set. Now we need to hollow out this cylinder. So we'll drag the cylinder whole. Again, we'll make it smooth. And we know that the inner diameter needs to be 21.9, so we'll make those changes. And if we drag this over, we'll drag to select both shapes, choose the Align tool, and align it side to side and front and back. I'll look from the top. This doesn't look right, so I'm going to click and drag both shapes again, click the Align tool. This will be easier to see if I change to orthographic view. Okay, once again, I'm actually going to drag that out, drag this one over here. Now click off both shapes, click to select both shapes, click the Align tool, align front to back and side to side. There, finally got it. Now while both shapes are still selected, I'll go ahead and click Group, and that creates the basic shell of the rocket with the outer diameter 23.4 and the inner diameter 21.9, leaving a shell of 0.75 millimeters in thickness. Now the last step would be to increase the size. Let's say I want my rocket to be 125 millimeters tall. So now I have my basic rocket shape. There's an alternative method that you can use. Instead of using cylinders, you can drag out a tube and again use the side slider to make it as smooth as possible. The radius we know is half of the outer diameter. The outer diameter is 23.4, so half of that would leave us a radius of 11.7. Enter, and we know the wall thickness should be 0.75 millimeters. So, hey presto, we've created our ring. Now we can make it as tall as we want, and so you see we've once again created a rocket body. Next, we'll take a look at the fins. We see that the critical dimensions for the fins are that they need to be 23 millimeters apart, that's the inner diameter, and that they need to be 1 millimeter thick. Otherwise, you're free to experiment with whatever size or shape fins you want. I'm going to stick with a basic triangular shape, so I'll pull out the wedge and tap F to zoom in, rotate to get a better view, and I know that the thickness needs to be 1 millimeter, so I will make that change. I note that this is by default 20 millimeters long, so what I'm going to do is duplicate and repeat, so it creates a duplicate copy exactly on top of this one. Now I'll rotate that copy 180 degrees, and then I'll switch the grid from 1 millimeter to 5, and using my arrow key, I'll move that duplicate over 5, 10, 15, 20. So now they're exactly abutting one another, and I need to move it over 23 millimeters more. 5, 10, 15, 20. I'll switch the grid back to 1 and tap my arrow key, 1, 2, 3. So now the space between these two fins is precisely 23 millimeters. I'll select both and group, and I'll look at them from the top. I'll drag out a cylinder to verify that that space is exactly correct. I'll smooth the sides, and I'll make the cylinder 23 by 23. And if I click and drag to select all of the shapes and center them front to back and side to side, I can see that indeed that is exactly the way they should be. So I'll get rid of that cylinder. Now I have two fins. I can leave my rocket with two fins, or I can click on the shape and duplicate and rotate 90 degrees. I now have four fins. If I select my first pair and duplicate and move up, tap F to focus in, I can click off the shape, click on it again, click duplicate. This time I'll move it over 60 degrees, and then I can tap duplicate and repeat again, and it will repeat that step. And so I now have 6 fins. And of course you can select all of them and group them so you have one easy section to manipulate, and I'll do the same for the 4 fins. You can have as many or as few fins as you like. You can add fins further up the rocket, but at the least you need some fins for the bottom. If I slide my rocket over, I can see that those fins are very small. That might be okay, or you might want to go back to the first step and make that first fin larger in size. Make sure, though, that you always keep the thickness of the fin 1 millimeter, and you always keep the distance between the fins 23 millimeters. Assuming this is fine for me, I'm going to look at the shapes from the top. I'm going to select all of them. Now I'll center them side to side and front to back and group them. So I now have a rocket with fins. Experiment with the size and shape of your fins and the number of fins and see if it makes a difference on how far your rockets will fly. For the nose cone, the only critical dimension is the outer radius, 11.7, so we'll look at that now. There is a cone shape, a paraboloid, under basic shapes, but if you search for high res, there's a high-res paraboloid that you can use. So I'm going to pick that one. It just has a smoother outer surface. And we said already that the outer radius needs to be half of 23.4, which is the outer radius of the rocket. So half of 23.4 is 11.7. We'll use the side slider, move it all the way up to the right to make it as smooth as possible. And now we can just figure out how tall we want it to be. Let's say I want this to be 30 millimeters tall. At this point, if you want to attach the cone to the top of the rocket so that it's permanently fixed, you can do so. But if you want the cone to be separate so that you can try different size and shape cones, we'll use an alternate method, which I'll show you in a minute. But first, for the permanent fixture, all we need to do is verify the height of the rocket, 125 millimeters. Click on the cone, grab the black arrow, start to drag it up, and then type in 125. We'll look at it from the top, select both shapes, choose to align them from side to side and front and back, and while they're both selected, click Group. We now have a hollow rocket with a solid cone on top that's affixed to the rocket body. So we could export this model as an STL file, slice it, print it, and launch it on the rocket launcher. What I'm going to do, though, is I'm going to ungroup those shapes, look at it from the top. With everything selected, I'm going to click Duplicate and Repeat, hold down my Shift key, and drag everything over. So now I will regroup that first set. So I have the one solid one. And for this one, I'm going to move the cone out a bit and then drop it back down to the work plane, move it closer to the rocket, because what I'd like to do is to have the ability to remove the cone and replace it with another one in case it gets damaged, or I could replace it with a different size cone. Maybe it'd be taller and pointier or shorter and more stubby, and we can try different launches and see which shape works best. So to do that, I'm going to close this and I'm going to drag out a cylinder, and I'll smooth the sides of the cylinder, And this cylinder, which will be underneath the cone, needs to be the size of the inner diameter of the rocket. So I'll tap F to zoom in, and I'll remind everyone that the inner diameter needs to be 21.9. So we'll change that dimension and that dimension, and we have a cylinder with a diameter of 21.9. Okay, so we see that this is 20 millimeters tall. We could change that height if we wish, but whatever height you decide on, you then want to lift your cone up that high. So in this case, I'll lift it 20. And now looking from the top, I'll select both shapes, align them side to side, front to back, and group them. Now I have my nose cone that will fit into the top of this rocket. Drag this over. We remember this was 125, so we'll drag this up 125. Look at it from the top. Select both. Center from side to side, front to back. Now select both of these and tap the F key. Look at it from the front. We know that the nose cone is going to be inside the rocket body 20 millimeters. So we'll bring this down to 105. 125 minus 20 is 105. Now I'm going to click on the rocket and tap the T key to make it transparent. You can also tap the color and choose to make it transparent here, because what we see is the interior of the body is hollow, so when the air pressure hits the inside of the rocket, it's going to pop the nose cone right off. So we need to add a solid pressure plate inside here below the bottom of the nose cone so that the nose cone itself won't be popped off when we launch the rocket. So to do that, we'll drag out another cylinder. We'll smooth the sides. We'll make the pressure plate 5 millimeters tall. I'll zoom in, and we know that this needs to be the same as the outer diameter of the rocket, so we'll make it 23.4 by 23.4. We'll look at everything from the top, select everything, center it side to side, front to back. Now we'll look at the rocket from below because I want to select just the pressure plate and then click front view. And now I can drag the pressure plate up as high as I want. So I don't want it touching the nose cone because I want to make sure that the nose cone slides in all the way. So let's say I'll make this 95 millimeters up from the bottom. Now I'm going to carefully select just the rocket and the pressure plate and group those two things. Now when I focus in, you can see that the rocket has a solid area there, and then from the top, you can see that the nose cone will slide right in there. So to print, select the body of the rocket, click Export as an STL, and separately, you'll click on the nose cone, click Export as STL. And this is what the printed rocket looks like.